Welcome to the Deep Dive. For those of you familiar with the constant push for better efficiency in metal cutting, rough cutting is often ground zero for potential cost breakthroughs.
Yeah, absolutely. It's a key stage.
So today we're diving into some innovations coming from Iscar. They seem really laser focused on upping the game in machining.
That's right. They put a lot into this.
And their key solution for, getting more done without sacrificing accuracy, it seems to be all about this fast feed tool technology.
Fast feed. That's the core concept we're looking at.
So our mission today is pretty simple. Really understand how these fast feed tools work their magic, why they're making such waves in the industry, and maybe what the tangible benefits are across different manufacturing sectors.
Absolutely. And even with all the sophisticated near-net shape manufacturing techniques out there, efficient rough cutting, it remains absolutely critical for keeping costs down. Our sources really back that up. And Iscar's dedication to this with their fast feed approach, it directly tackles this core need. The fundamental idea, maybe for those more acquainted with traditional methods, is this shift. You move away from taking really deep cuts at slower speeds.
Okay.
And instead, you use very shallow depths of cut, but combine that with significantly increased feed rates.
Okay.
And this allows for much, much faster material removal, especially in those initial roughing stages, crucially, without putting undue stress on the workpiece or the tool itself.
Okay, so this idea, shallow cut, high feed, it sounds almost backward, doesn't it? Especially if you're used to thinking about just hogging out material quickly.
It does seem counterintuitive at first glance.
So what's the underlying engineering? What makes this seemingly less aggressive approach actually more effective?
Well, what's really fascinating here is the clever design behind Iscar's fast feed tools. They incorporate these advanced geometries, right? And they're specifically optimized for really efficient chip evacuation.
Chip evacuation, okay. Like getting the waste material out of the way.
Exactly. Think of it like a highly efficient waste disposal system, right there at the cutting edge. This stops chips from, accumulating, which can generate heat and cause damage both to the tool and the part.
Right. Heat is the enemy.
And crucially, these geometries also play a key role in managing and reducing the forces involved in the cutting process itself.
Okay.
By minimizing these forces, they significantly decrease wear, not just on the cutting tool, but also on the machine spindle. And that contributes to the overall reliability and, frankly, the lifespan of your whole machining center.
Right. So less resistance, less heat buildup. It all points towards longer tool life and healthier machines overall. And our sources really highlight that these tools aren't particularly fussy about materials either.
No, not at all.
Handling everything from common steels right up to really challenging stuff like titanium and those high-temperature superalloys, HTSA they call them. That kind of broad applicability, that must be a major advantage for shops dealing with, diverse jobs day in, day out.
Precisely, yeah. If you connect this to the bigger picture, just for a manufacturing operation, the ability to use a similar tooling strategy across a wider range of materials, it really simplifies your tooling inventory.
Good point. Less complexity.
Right. And it speeds up setup times between jobs, and ultimately it just streamlines your entire production workflow. This is particularly beneficial, as you can imagine, in sectors like aerospace or automotive or die and mold, where you're routinely working with a whole variety of different alloys and material properties.
Okay, so we're talking faster material removal, less wear and tear, broader material compatibility. But what are the real bottom line impacts for a business? What kind of concrete advantages do companies actually see when they adopt this fast feed technology?
Well, the primary benefits, they're quite compelling, especially from a business perspective. First and foremost is just the substantial reduction in machining time. It's significant. By feeding the tool at a much higher rate, you naturally complete the machining operation much, much faster. In high volume production, where you're making thousands, maybe millions of parts.
Yeah, the numbers add up fast.
Exactly. Even small reductions in the cycle time for each part can translate into enormous cost savings. Huge.
Wow.
Secondly, despite their primary role being in roughing, these tools are often designed to provide a good enough surface finish that in some cases you can actually reduce or maybe even eliminate the need for secondary finishing operations.
Really? So potentially skipping a whole step?
Potentially, yes. And that, again, saves both time and money. And finally, that extended tool life we mentioned earlier.
Right, the durability.
Which comes from the advanced materials, the coatings, the optimized geometries. It means fewer tool changes, less machine downtime, and that directly increases your overall production capacity. Simple as that.
It sounds like a cascade of positive effects, really. Faster processing leads to more output, potentially better initial surfaces mean fewer steps later on, and longer-lasting tools keep the machines running, making chips.
That's a good way to put it. A cascade effect.
Our sources even give us some insight into how this plays out in specific industries. Let's maybe start with aerospace. That's where machining those incredibly tough materials is just a constant challenge.
Absolutely. Yeah, machining materials like titanium and those high-temperature superalloys, HTSA, in aerospace, it's notoriously difficult. They have inherent strength resistance to heat.
Tough combination.
Very. Our sources suggest that manufacturers adopting fast feed in aerospace have reported cycle time reductions of, well, in some cases, significant percentages when machining titanium. We'd need specific figures, but the trend is clear. Fast feed tools just offer a more effective way to machine these materials. They achieve higher metal removal rates without generating excessive heat or causing premature tool failure, which, as you know, is absolutely critical for producing lightweight yet durable aircraft components.
And then we have the automotive sector. Very different pressures there. The name of the game is high volume, rapid production.
Exactly. And that high-velocity environment of automotive manufacturing, meeting incredibly demanding production targets while maintaining really strict quality standards, is paramount.
Non-negotiable.
Right. Fast feed tools enable manufacturers to achieve those high material removal rates needed for mass production. It helps them keep pace with market demands without compromising the precision needed for critical automotive parts.
And what about the die and mold industry? You're often dealing with very complex shapes there, sometimes lower production volumes compared to auto. What's the key advantage in that space?
Yeah, for die and mold makers, the benefits really lie in, well, both the reduced machining times, which speeds up the often lengthy process of creating these intricate tools, and also the improved initial surface finishes.
Ah, the finish again.
Yes. And interestingly, the data we have indicates that while traditional roughing might require multiple tool changes for complex mold cavities, fast feed tools can often complete the entire roughing operation with just a single tool.
Wow, one tool.
Often, yes. Significantly reducing downtime. And achieving that better initial surface can also significantly minimize the amount of manual polishing required afterwards. That saves considerable time and labor in producing these complex forms.
Okay, that makes a lot of sense. Now, Iscar doesn't just talk about fast feed as like a general concept. They have a specific lineup of these tools, right?
They do. A whole portfolio.
Let's maybe delve into some of their offerings, starting with their fast feed turning tools. What are the key differentiators there? What makes them tick?
Okay, turning tools. The information we have highlights several key aspects. They're specifically engineered to handle those high feed rates we talked about,
right,
which directly translates to shorter cycle times in turning ops. They're also constructed from very durable materials designed specifically to withstand the stresses of high-speed machining, ensuring reliability in demanding applications.
Durability is key at those speeds.
Absolutely. Precision cutting is another core feature, minimizing tool wear and maintaining accuracy over time. And mirroring the broader fast feed philosophy, they offer pretty broad versatility across a wide spectrum of materials and turning applications.
Okay. Moving on to grooving and parting tools, those processes can often be a bottleneck, can't they, in overall production time. How does the fast feed approach improve these critical operations?
Yeah, grooving and parting speed and efficiency are absolutely crucial there. Iscar's fast feed versions, they're designed specifically for high-speed performance, enabling quicker, more efficient creation of grooves, and also the separation, the parting off of finished parts. Again, the emphasis on durable materials is there for extended tool life.
Consistent theme.
It is. And the inherent high feed capabilities directly lead to reduced cycle times, which boosts overall throughput. Consistent performance and achieving high-quality results are also paramount in these operations, and these tools are really engineered to deliver precisely that.
And then we come to milling. This seems to be a significant area of focus for Iscar with their fast feed technology. The material we looked at really emphasizes the increased machining efficiency and productivity here.
It is a major focus, yes.
What's the fundamental principle at play with their fast feed milling tools?
So the fundamental principle with fast feed milling is really to achieve dramatically higher material removal rates, MRR, and shorter cycle times, specifically in milling applications.
Okay.
Our source material actually goes into the critical role of the milling cutter geometry in achieving this. The design prioritizes efficient chip thinning.
Chip thinning. Explain that a bit.
Right, so chip thinning becomes absolutely essential when you're feeding the tool at such rapid rates. By sort of thinning out the chips as they're being cut, You effectively reduce the load on each individual cutting edge.
Spreading the load.
Kind of. And it also decreases the overall bending forces acting on the tool itself. The material points out two main geometrical approaches to get this done. One involves a cutting edge that follows an arc, like a segment of a large circle.
Okay.
And the other uses one or maybe two straight edges that function like chords of that arc. Both of these designs effectively achieve the necessary chip thinning and contribute to a more stable, more efficient milling process.
That's fascinating. The subtle but really crucial engineering just in the geometry of the cutting edge itself.
It really is. It's quite sophisticated.
And it sounds like Iscar has really integrated this deep understanding into the key features of their fast feed milling tools.
Absolutely.
Yeah.
The high feed rates, they're the primary driver, obviously, for achieving faster machining and reduced cycle times. But this capability is totally underpinned by the robust construction of the tools.
The materials again?
Exactly. Utilizing high-quality materials to ensure they can withstand the demands of high-speed operation and maintain a long, predictable tool life. Precision and stability are also vital, ensuring accurate cuts and minimizing tool wear even under really aggressive cutting conditions.
Right.
And aligning with their other fast feed products, these milling tools are designed for versatility, making them suitable for a wide array of materials and applications. And finally, their innovative design, incorporating those advanced geometries we talked about and specialized coatings, it further enhances overall performance and ensures effective chip evacuation, which, as we discussed, is just critical for the success of high-feed machining.
Okay. To give us maybe a clearer picture of their offerings in this milling area, our material highlights a few of Iscar's popular fast-feed milling product families.
Okay. It is characterized by its use of double-sided indexable inserts.
Double-sided indexable, meaning?
Meaning each insert has cutting edges on both sides, so you effectively double its lifespan before needing replacement.
Clever. Better economics.
Exactly. A significant cost advantage per edge. These tools are engineered specifically to deliver high feed rates across a pretty broad spectrum of milling applications.
Okay. Next up is NeoFeed. What's the standout feature of that product family?
NeoFeed also focuses on high-feed milling, but it utilizes cost-beneficial double-sided square inserts.
Square inserts, okay.
Similar to ECLI 6 feed, the double-sided aspect gives you more cutting edges per insert. Square geometry offers a really good balance of performance and economy, making it a pretty compelling option for many manufacturing environments.
Got it. And finally, we have the Multimaster. Now, that sounds like it offers a slightly different kind of benefit.
It does. The Multimaster system takes a slightly different approach. It's a modular tooling system.
Modular.
Yes, it features exchangeable cutting heads. This provides a significant advantage in terms of enabling very quick tool changes. That minimizes machine downtime and directly boosts overall productivity.
So less time fiddling, more time cutting.
Precisely. And the modular design also offers great flexibility because you can rapidly swap out different cutting heads on the same tool holder body to suit various milling operations or materials.
Very versatile. So across their entire fast feed lineup then, from turning and grooving right through to these milling systems, Iscar's strategy seems to revolve around that central principle. Achieving high feed rates made possible by intelligent tool design and robust materials, all ultimately aimed at maximizing efficiency and minimizing costs for the end user.
That's an excellent, concise summary. I think that captures it perfectly. Iscar's fast feed tools, they truly embody their commitment to innovation in machining. They're not just, refining existing technologies slightly.
It sounds more fundamental.
It is. They're fundamentally re-examining how material can be removed efficiently and with precision. By carefully considering the interplay between cutting tool geometry, advancements in material science, and the sort of real-world demands of contemporary manufacturing.
Right, the practicalities.
They are delivering solutions that directly address industry challenges and, frankly, are establishing new performance benchmarks. Their dedication to meeting and often exceeding both industry standards and customer expectations is clearly reflected in the comprehensive nature and the sophistication of their fast feed product offerings. They are undoubtedly playing a pivotal role in shaping the future of faster, more precise, and more cost-effective manufacturing practices.
Absolutely, it's quite compelling. So to quickly recap our deep dive into Iscar's fast feed technology, We've seen how their core strategy, using shallow cuts with high feed rates, enabled by sophisticated tool designs and durable materials, is really transforming rough cutting operations. This translates into significant real-world advantages. We talked about substantial reductions in machining time, significant cost savings, increased production output. And that's across a wide range of industries, including aerospace, automotive, and dye and mold.
Key sectors, definitely.
And Iscar's extensive portfolio of fast feed tools, covering everything from turning to milling, clearly demonstrates their strong commitment to innovation and effectively addressing the evolving needs of modern manufacturers.
Precisely. And that consistent emphasis on things like optimized chip evacuation, the reduction of cutting forces, and that broad versatility across a multitude of materials, those are all critical factors that contribute to the success and the overall impact of this innovative technology.
Yeah, it's a well-rounded approach. This has been a truly insightful exploration into how innovation in cutting tool technology is directly tackling those fundamental challenges of manufacturing efficiency. Now, for our final thought to leave you with, considering the relentless pace of advancements we see in both materials science and manufacturing processes themselves, what future breakthroughs in cutting tool technology might we witness? Something that could further revolutionize efficiency and precision, maybe even beyond the current impressive capabilities of fast feed tools? And what entirely new limitations might these future technologies be designed to overcome? It really gives you something to consider about the ongoing evolution of the manufacturing landscape.
A fascinating question to ponder.
Indeed. Thanks for taking this deep dive with us.